remember well. Oh, hello. Um, yeah, my name's Jack. I'm a postdoc at the Intelligent Instruments Lab in Reykjavik, Iceland. And I just drove 10 hours across Iceland straight to the airport and landed here and came right here. So apologies if I'm not looking quite with it. Um, so yeah, it's my first time at this conference, and I'm really excited to meet all of you. I'm giving a talk tomorrow morning about A-Life combined with interactive machine learning. I work mostly with real-time interaction in creative contexts, making installations, musical instruments, experiences, and I I procrastinated my way to a Python library because I felt a need to have a more modern Python-based workflow for doing like real-time interaction with A-Life, and that's what this project is, Tolvera, tolvera.is. And so it's based on the Tai Chi language, which probably some of you know. And really the idea is that it's kind of, for me, it's kind of like the missing creative coding library for A-Life. So if you've used tools like p5.js or processing, that kind of thing, this should feel quite familiar to you. Um, so the basic idea is that you have a render function that returns some pixels, and that's going to run perpetually. And within that, you can do whatever you want. And Tolvera has various inbuilt modules um, that you can also extend. So there's this like Vera, which is the Icelandic word for being module, which includes some very simple A-Life models. And part of the reason I came here is hopefully you can all blow my mind by making much more interesting ones. There's an inbuilt particle system. There's this kind of n-dimensional state structure that means you can kind of compose together different types of A-Life. So to give you a clearer example of what I mean by that. So for example, this is Game of Life and Boyd's, but they're kind of having a real wrestling match here or something. So because the state that is calculating the particle system and the Boyd's blocking algorithm can be shared with the Game of Life state, it means you can do these like mashups, which is very unscientific. There's no scientific reason I can think of why you would want to do this. But as an artist, it's exactly what I want to do. Maybe you can find a scientific reason. That would really help my funding applications. So get in touch if that's on your mind. But yeah, in terms of more sort of interactive stuff, let's see. This never really works that well on Zoom, but is it going to work? No. Should be doing some hand tracking, but oh, there we go. Yeah. So now we're attracting our particles to these points tracked on my hand. And there's also like face mesh tracking and full body pose tracking. So I've been collaborating with dancers with this, which is pretty nice. How am I doing for time, by the way? Yeah, you just tell me when to shut up. Yeah, what else? There's inbuilt sonification. So I'm kind of wrapping like other creative coding libraries into this. So for anyone who's kind of a music nerd, Open Sound Control is this kind of Ethernet-based protocol that music software people use to communicate between apps and so on. So that's like heavily built in, which means you can control your A-Life program from Ableton Live or a MIDI controller, some hardware device. You can also do interactive machine learning, so training little machine learning models on the fly that give you like an input and an output vector that can control arbitrary things. I've been using that to control grand pianos and stuff. Pretty fun. Um, what else was I going to show here? Yeah, sonification. Uh, there's a really cool library. If you're interested in sonification and you do Python stuff, definitely check out Signal Flow by my friend Daniel Jones. It lets you write code like this, and you can make sounds. So obviously, we want to know what all our A-Life programs sound like. Um, so yeah, my audio devices are getting kind of confused here. Why are we not hearing that? Uh-huh. So I don't, maybe, yeah. Yeah, let's go. All right. Instant rave. And and now we have feedback going on. Whoa. So you get the idea. We'll stand over here. Um, yeah. So if you like creative computing and you want to procrastinate on your science, give this a try. But actually, I do want to see if it would be useful for people doing more empirical studies. In theory, it does scale up to like actual offline, larger scale experiments because it's all just Tai Chi GPU code. Um, yeah. Any quick questions?